Hi everyone, welcome to Velonte's data analysis webinar. So this webinar is like we kind of show you like how to do a live data analysis project. So it's going to be quite interactive. And one of the things that you might be thinking right now is, oh, let's just go straight into Excel or go straight into Power BI to analyze a data. The question is, data analysis, is it complex? Is it simple? Is it something that I can learn if I put my heart to it? And this is what we want to really show you today. To show you like the level of complexity or the level of simplicity it is to become a data analysis analyst or data expert, data scientist, or whatever. In our previous webinar, we spoke about like the various career pathway options, but today we won't be talking about that. And so let me just show you a brief sample of what we'll be doing today, like the end result. Then we'll go ahead to go through the process. So this project is one of the project of our past students, and this is what they did. This is like a report. So they wrote a report about the analysis. This is some visualization. There's another visualization. This is another visualization. For this, I don't know what visualization means. Just like a visual or something. Another visualization. This is another one. And they had references. So this is telling you that so data analysis is not just like writing like analysis, right? It's also about like reports. So this is like the Power BI that they ran. You see how quite neat is this? And this was done by a student, right? So you see just show some insights. And this is like just a student project. So think about what you can do, let's say when you are sort of working on a lot of projects. And this is their Excel um reports. So they did to look at this pivot table. So it was they have a lot of analysis in your Excel sheets than what they had in the report, and that is what is like happening in most times when you do your analysis. So this is they did this dashboard in Excel, transform data, all and all. So let's do something a little bit practical and find the data ourselves. Like this is not so what I want to try to do is not just um trying to like run analysis about something that is ready made. So we're going to like sort of find the data by ourselves. And we can do this by going to a website called cargo.com. So cargo.com is one of the top websites for you to get data. So it's called cargo.com. Cargo. So you just go to www.cargo.com. So your interface might not look like this. Um, but if you want to download the data, you will need to first of all have like an account created. It's just simple, same Google, create an account and you'll be fine because you can't download data set without having a account with Cargo, and having an account with Cargo is free. So if you have an account, you probably have something like this on your device. You click on data sets, then you could search for literally anything. Let's uh, say marketing or like maybe sales data, right? Sales. So how do you know if a data is great or not? You could come here to filter by like hotness or most votes. So I usually use most votes. So it means that people really said the data was good. And if I want to download the data, I'm going to try to download the data that just have one or two files. When it has multiple files, it's like complicated. So it just has like one file and all. So let's just download this random supermarket data and see if it's a good data. So the question is, how do I know if the data is a good data or not? So download this. It's going to prompt you to do this, but this is for those who are using like Python or maybe using R. So you don't have to download the data. You can literally just do this and it's going to work. So we have this downloaded. Let's see if this is a good data or not. So when we open it, we'll know if it's a good data or not. So when something is a good data, I'm trying to just do something random so you could literally replicate yourself. For it to be a good data, you want to see numbers and you want to see texts. So these numbers data, usually they are called, I didn't say all the time, these numbers data, usually they are called numerical data. And these text data, usually they are called categorical data. So there are some underlying principle that you have to understand that is going to guide you in doing data analysis for any project. So it is more like if you want to write an essay, either you use a keyboard or you use like a Mac or Windows. There are fundamentals of writing. Like you have to start with capital letter first. You have to have space between your words. There have to be paragraphs. You understand all of those things. So I want to just do a quick overview about that before we go straight into this analysis and call, let's say, one or two persons to jump on and say, oh, what do you think we can do here? What are your thoughts? To tell you how, even on this spot, for somebody who can think or can really remember stuff or can just, I mean, smart would be able to figure out what data analysts should do without having to take any course or know anything before about data analysis. So, like I said, for you to know if your data is a good data, when you download it, you want to see text data, you also want to see numbers data. So that is that about that. So let's go back to a little bit. Let's just give you some sort of background as to like um some data analysis like background that you need to know. So mind you, if you notice, this is a copy of part 5, part 6, part 8. This is actually moving on from part 1 to um this is moving on from part 1 to like a lot of like parts, but these parts are quite like a very important part. So there are some like parts here that like maybe or some discussions that are like foundational that would be helpful to like understand whatever we want to say in this part 5, 7, and 8. And this part 5, 7, and 8 is just like we just go scan it. And in case you want to like learn more, we'll talk more about that at the end of this visual training. I just wanted to show this so you have like context as to what we're doing. So let's just quickly go. So type of questions that you could ask as a data analyst. So let's say you have a data set. So this training is just not for you to be able to analyze just one type of data. It's like you should be able to transfer this knowledge to any type of data you want to analyze. So you have to have questions in mind before you go ahead to see like say an Excel sheet that you have here. So for instance, let's just see what we have here. We have invoice, we have branch, we have city, we have customer type, we have gender, we have product line, we have unit price, we have quantity, we have tags. So based off of this data, like um like you see that the name of data is supermarket sales, but imagine we don't have something called supermarket sales. I don't know if anyone could try to look at this and say, oh, what do you think if somebody gives you this data set and say, help me analyze this, what do you think is the most important like variable. Let me call. So these are called variables. What do you think is the most important variables that you'll be looking at? Anybody wants to like, based off of what you have here, are you going to be looking at invoice or brands or city or customer type? Or like first of all, what variables do you think is like one of the most important or variable is the least important? Anybody want to go? In your way, please.
I am thinking the customer type.
Okay, customer type is like one of the most important. What do you think would be a least important variable here?
The list should be
I feel like I don't
sorry,
think what this does this even make sense.
I think the city.
Okay, the city. So yeah, I think was the city, okay, city. Okay, yeah. So this that makes sense. Like I mean city is one of like in the least important, but not the most least important. So thank you so much. I think you mentioned customer type. So this is just basically like how data analysis work, and I'm going to come back to like how you would know this is least important and techniques and all like that. So thank you so much. Anybody else just want to like add anything? What other variable do you think apart from customer type that you feel like, oh, I think this variable, yeah, it's like based off if somebody send me the data, this is like a variable I'm going to be looking at first of all and all of that. Anybody? Okay, I'm probably just gonna skip and come back to it. So going back off to this, right? So understand that it has to be like questions you have to ask. So let's say you want to just ask it, is this an analysis? We need to write the report. Um, so you need to ask, what's the overarching goal or question? So let's come back to this data again. When somebody sends you this data set, like ideally they are like human beings, like right? So before you start digging into like what they are looking for, ask them like why do you have a question in mind? What are you looking at to get from this data set? Because some people might have something they want to really solve from a data set, but unfortunately their data set might not be able to solve it. So let's say this person is saying, give me the total sales by um say ethnicity. So for example, we don't have an ethnicity variable here. So how do we sort of like get up ethnicity? So it's not possible, right? So so you need to know what's your overarching goal. So for example, looking at this like example of data that we have here. So we have income, we have children, we have gender, we have urbanity, we have rating, we have marital status. So yeah, you want to explore the demographic factors on income. You're like, oh, demographic factor, what's the demographic? Oh, I think gender is a demographic factor on income. Oh, to look at the average sales for each product. Average sales, we don't have sales here. Then we can't do that yet. So right. So can we break the question into more specifics? So just breaking down the question, skim and scan the data set. So before you are afraid about, oh, this is so many information, you can have the data set as like a lot of columns and rows. So just try to quickly skim and scan through the data set. Um, you so I think I'm just going to skip. So you picture what the analysis is going to look like before we end, and all of that. So let me just skip this and go to part 7, data cleaning and readiness. So most of the time, like majority of the time as data analyst, you 60 to 80% of the time you are cleaning your data. Yesterday I was still working analysis. I could literally be figuring out something for 3 to 4 hours. And it's just like quite like interesting, right? You could literally just be cleaning the data just to ensure that things are working fine for like hours. So this is like data analytics, right? Technique. So cleaning. So how do you what are the things that you do for cleaning? So cleaning can involve like trying to rename columns and row, remove empty on all values. So for example, look at this sample of data. We have like empty empty columns. So just so you know, when it is vertical, like a straight line like this is called vertical. This is called rows. When it is horizontal, it is called columns. So just do a reverse direction of what you were taught when you were in your primary school, or elementary school, when it said, "Oh, all of you on this row, stand up." So what it meant to say, all of you on this column, stand up. So, so column, you need to, these are like really technical terms for you to understand. And I'm going to be using these terms as I proceed or do the like real life analysis. So these columns, so you might want to see that we might have empty columns. In the real world, most of the data is going to be like messy and unclean, and you have to like clean them first of all before you do your analysis. So you can have empty columns, you can have wrong labeling of the names. For example, in data analysis, um, the fact that something is capital F and small letter f, so we know that gender, this is going to be like female and male. Imagine somebody wrote female FE capital letter F, and another one writes female small letter f. According to this Excel sheet or whatever platform you're using, it's going to recognize it as two separate things. So if you want to do like a bar chart for your gender, you're going to see female small letter all through, and case capital letter. So that's sort of like a data cleaning, and that's not what you really wanted. So so that's like one of the ways to like clean your data. So how do you even know if your data is okay? You could just run simple visualization. Maybe you run like the mean. So let's say you run a mean of these children and you find out that the mean is basically the average of a particular set, or maybe a column or whatever. You run an average of this mean and you see that the children, you notice that the mean is like 50, and like this is not possible. Like how would the average number of children be 50? Maybe somebody mistakenly wanted to write two children and they inserted 200. So that is also part of like data cleaning. So so you could be thinking about that. So it's more thinking than just rushing into like the analysis. Dealing with outliers, I'm not going to talk about that. Just going to go straight to this one. So I think this is quite like the most important one I want to talk about before I dive straight into the analysis. So you you need to know that analysis is called garbage in, garbage out. It's like Gigo. So you need to know the data type, have an idea of what the results will look like, being able to judge other results, differentiate between what is a good and bad result look like. So there's something called, you see here, we have it called recall, meaning that in previous videos or previous slide, we must have talked about this to those who are enrolled. So univariate and bivariate and multivariate level of analysis. So univariate level analysis is saying that, let's say you ask, what is the average income of the respondents? So respondents are people who are like in the analysis, or what's the average income of everyone in this data set. That is a univariate. So we are just going to use just one variable, right? So if you now start to say, what's the average income by say sex? So other than age, I would rather say sex. What's the average income by sex, or by, let's say, by age groups, maybe by generation or whatever. Multivariate is like, okay, what's the average income by sex, by rurality and income, right? So you are adding more than one variable. So it's like quite informative. Uni means one variable, that asking a question that just require one variable. Bivariate means asking a question that requires two variable. Um, Multivariate means a question that requires three or more variable. Are you guys tracking with me? Like, are you guys on track? Are you guys getting what I'm trying to say? These are fundamentals to like what we'll go ahead as to start our analysis. Are you guys with me? Any question? Any question? Okay, I'll assume no question means you guys are understanding, or you don't even understand at all. So, very level
We are
analysis.
understanding.
Good, thank you so much for that. So for the univariate level of analysis, I said it's one variable. So we can have something called income, height, salary. So remember when I said that when you download the data set, you want to have a text data and you want to have a number data. Normally, because I don't want to go into details and go to the granularity of it, so I'm just going to quick things quite simple. Mostly when it's a number data, I didn't say all the time. Mostly when it's a number data, it's a numerical data. It's a numerical data. And when it's a text data, it's a categorical data. So a lot of times things around us are quite categorical, like, oh, I'm either a male or a female. I'm either like I've eaten or not. Like I am this or that. Like there are groups. So like we most times as data analysts or whatever, we want to see there's variation across groups. Like or maybe the government is trying to like have a budget. They are trying to figure out oh which state should we give more resources to. So that's why they say, oh, this state has more persons, more population. So we are looking at variation across groups. So why numerical data is like numbers, right? So you're trying to say, oh, this number, is it high? Is it low? Average sales. So the kind of analysis you run for a numerical data is different from the one you run for a categorical data. In that sense, I really don't think like the kind of analysis you can run for a numerical data is the same as the one you run for a categorical data, right? So let's just go to like this sheet here, right? Before we kind of talk about the kind of analysis you will need to run for a numerical data and a categorical data. So for a numerical data, when its data is number, so you do something called measure of central tendency, like the mean, median, mode, range, or you do an histogram, or you do a line graph. So analysis you should not run for a numerical data, bar chart or pie chart. So you see what they are and all like. So this is a for numerical data, this is an histogram. So we just see looking at the age, right? So we want to see like the distribution of the age. You could just do like a median or whatever. You could also see um this, like this is a pie chart, right? So you should not do a pie chart for numerical data. So what is this saying? So imagine you have a number one, this is 1 to 9, and you do a pie chart for this. Let's now imagine the number is 1 to 100. Like that means you have like 100 pie, like 100 bunch of pies. So it doesn't make sense. So yeah, this is like a bivalent analysis, but because it's two stuff, right? But let's just stick to this. Reason why you can do a line graph for this is because of it is years. So when something is like years, years can actually be seen as a category called numerical data. They are disguising. So I'm not going to go into that. So, but just try to know for numerical data, you either run mean, median, mode, things like that. Like what's the average income? What's the highest income? What's the range of the income? So for univariate, so you also have like categorical data. So we have sex, rurality, product type. So you do like a bar chart, pie chart, tables, line graph. Others are donut chart, bar, pie. So analysis you should not run. You can't run a like mean. Say let's say you want to run a mean for states or mean of sex. What does that even mean? Like if you say, so and that's what people will do. Some people say let's run a mean of a sex. So your computer might be able to run it. Let's say you represented females with one and males with two. So if you run the mean, that's 2 plus 1 is 3. 3 divided by 2 is 1.5. What does 1.5 means? So it's not just about running analysis right. It's like doesn't make sense. So that's why I'm not going to jump straight into like doing some bunch of stuff in Excel for you. And you're like, oh wow, we're doing this. How can I replicate this for myself? So categorical data. So we have bar charts, pie charts, basically stuff that can group people category like a visualization. So we say this is a bar chart. So if you have like a survey and people filled in agree, disagree, neutral, so you can see how many people filled in disagree, how many people filled in neutral. So this is like a bar chart, which makes sense for a categorical data. this is making you feel like if you really don't know anything about data analysis right now, that look, this is very simple. I could literally wake up and somebody tells me this in like 10 minutes, and I'm like, yeah, I'm a data analyst. So categorical, but it's more than that, right? So this is also like you do like a table or you do like a pie chart, like it's a pie, like me pie. So pie chart. So you say we have tea, coffee, cola, water. So this is when you have groups, and there are also times whereby you can't run a pie chart. Imagine you want to do a pie chart for 36 states. It's going to be messy, or like 50 states. So you don't want to do that, right? So there are some other things you could do. So by rate analysis is when you have two so private analysis is when you have two variables. So there's a condition one. Condition one is when you have two numerical variable, age and income. So type of analysis you could run is scatter plots, measure of standard tendency, regression, coefficient correlation. I'm not going to be going into all of this analysis today. Analysis you should not run is a bar chart. Vibrate analysis, this is, let me not go into this. Let me just skip this one now. So most of the times, this is the type of bivariate analysis that you run. One categorical, one numerical. You have sex and income, um, bar chart, pie chart, all of that. So this is a bar chart. This is um. There's something we also call y-axis and x-axis, and I think we're just going to show you that in a bit. So this is like the categorical data here, the check, credit card, and we also have the numerical data on the y-axis. So this is the y-axis here. So something that is vertical. The vertical line is the y-axis. The horizontal line is the x-axis. So you have the categories. So most times you have the categorical data on the x-axis and you have the numerical data on the y-axis. And you could literally also run like a table. Let's say you have so many levels, you don't want to put like say 50 states in a bar chart. Maybe say you want to see what's the average sales or average GDP for each state. It's going to be too much of information. You could just do like a table where you have like the top 10 or the least 10, or you have like a filter visualization. So this is not, we're going to talk about that today. So by very two categorical data, you really have this type of analysis, but if you have them, you probably run a kite square and things like that. Multivariate. So this is where you have three. We're not gonna do this today, just show you some things you could do. So you see, like this is noisy. You don't want to do this. I don't want it to show by you do like this class today, and you go ahead to like want to run your analysis yourself and you're doing this type of visualization. So for any visualization, when you look at it, it has to make sense visually. It has to be appealing. So you have to like, wait, what's this saying? Can somebody who is a data analyst understand this? There are a lot of things wrong with this. Also, what is wrong with this? This is a wrong scaling. Look at the way they did it. On their on their y-axis, they started with 58% till 78%. So they made it look like there's a wide range with difference in 77 and 65%. So this is a type of a bad visualization. Um, this is also like a bad one. Looking at the color, it's like 75, 78. What does that mean? So getting it right, family getting it, the economy, even though like it's just three groups, what does getting it mean? So whatever you're going to be putting, it has to be quite descriptive. So that's like what we're trying to say, that as data analysts, what we do is quite intuitive than just like jumping into data. So earlier on, for those that just joining, I just randomly downloaded this data on Kaggle. Kaggle is a website for you to be able to download data. It's kaggle.com. I literally this data is I'm just downloading it now. So we are going to like do like just random analysis ourselves. So what are like the first steps I'm going to do um if I have a data set? So and that's like what I'm trying to run everyone through right now. Oops, 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 oops. Okay, okay, okay. Why is this? One second. Okay, interesting. It's nice. This is oh shit. What's wrong with this? Okay. So I randomly downloaded this data set on Kaggle. So if I were you want to run this analysis, these are the few things I would do. I'll either like create a save this data as sort of file, save a copy, save as, and create like a new, let's say something called my analysis, like so that you have a copy of the data, or you could literally just like copy everything here, Control C, you open a new sheet, placing your data. So this is like first standard practice. So data copy. So you want to, when you have analysis or you have a data or anybody send you data, you want to create a copy of the original data. That's like the first thing that you would do. So when you create a copy of the data, so we are like confident as to, oh, let's take out things or want to make changes or things like come up already and you're like, oh, I forgot to add this. Then you have like this sort of relaxation. So when you look at the data, so let's just use this type. So we have invoice ID, branch, city, customer type, gender, product line, unit price, quantity, tax, 5%, total 5%, and payment codes. So let's start with some, and I'm gonna like try to call names, and you guys could help. So let me tell you, earlier on, I asked what is like the least important data sets that we have here. Most of the data sets you download, they usually have something called like ID. ID is like a unique identifier. Um, for example, if you're in a functional country, you would have like a unique identifier number, and that number, nobody should have that number again. So that number is such that they would recognize you. If you are in a university, you would have a unique identifier called like a matric number. If you whatever, like most of the systems or most platforms will have a number that uniquely identify you that is just given to you. So when you have a unique identifier in a data set, you can't run an analysis with it that makes sense. So let's say somebody says, what's the average matric number? Or what's the average NIN number? It doesn't make sense. Like let's say even like we have all like 1001, 1002, 1004, and somebody says, oh, like can somebody get the sum of all the matric numbers we have, all the IDs? Like, does this make sense? Anybody like, does this really make sense? Anybody wants to like, do you think it makes sense?
No, no, it doesn't.
Yeah, yeah. So we see like it doesn't make sense, right? So most times when you have a data set and it has like a unique identifier, first off is you want to take it out because probably in the analysis we might not need it. So an unique identifier is like um numbers, like random numbers, like looks like a phone number or whatsoever. So invoice ID, you need this when you are doing some like let's say SQL kind of thing. So like merge different data sets together, but that's not what we are doing today. So for this type of analysis, we want to do some visualization. So you first of all delete it. We are deleting it because we are confident that we have a copy of it. So most times in analysis, we are trying to look at things at the aggregate level. So when things, this is one tip I'll give you. So when you have a text data that the text data is unique, in case you're writing this, I just noticed. When you have a text data and the text data is unique, you cannot really get a visualization from it. Let me give you another example. Imagine there's a column called customer name. Customer name. So you're like, oh, why not just going to straight up Excel sheet? That's what that training program will do. We have something called John, we have Doe, we have Jane, We have Jack. Um, we have Jean. We have Joy. I mean, anybody wants to give me like names, more names? Let's just get like more names. More names.
Joe.
Joe. Okay. Any more names?
Mark.
Mark. Okay, let's stop there. So let's say somebody says, do a bar chart of like the names that we have here. Like literally, you're gonna have like, let's say, imagine this is a bar chart, right? And like this is another one. This is like a line. This is another one. And you're like, oh, because it's a categorical data, it's a text data. You know, do so maybe John will have like one frequency because this is going to be the frequency, right? On the y-axis, like Joe is going to have one. So it's like it's not making sense. So when you have a text data that they are unique, that it looks as though they might not be unique. You might have another John here, right? But like it's already looking like this is too many information, like this too many difference. It looks very unique. You can't run I mean it's direct example say, oh, let's know how many John are in this word. Maybe I've done those kind of analysis. So let me see how many Jane are in this word. So you can run analysis based off of that. So you also delete that. Let's say you have a data that has this. So you delete that also. So can somebody think of like another possible like customer information or like people information that you think if it's in this data set would not make sense to run analysis with? What do you think?
Address, customer address.
Exactly. So customer address. So let's say you have somebody says, oh, I am living in 15 Mark Turkey Street. Somebody says I'm living in 17, like so far like it's unique, right? So let's say it's not like maybe for example like the city or the customer, which we can have like a lot of city. We have Yangon, Niptia, or whatsoever. We're like, oh, okay, so we can do stuff here based off of the city. Now that could be like phone number, right? Or 832, something like that. So we're getting that. Um So going off of this, most of the times the column names are going to be quite descriptive. Sometimes they would not. So if you have this data, I don't know what cogs means. So I probably have to like maybe activate some people with data like what does cogs mean? So let's first of all we start with deleting things like elimination because the lesser columns you have, the lesser you're able to come up with the kind of analysis you could run. So this is called branch A. So we know that, oh, we have different branches, cities, customer type, gender, product line, units. So you can say date. Do we think we need a date? Do you think we can delete the date? Anybody, do you think we can delete the date?
I don't think so.
Okay, why do you think we should leave the date?
Because if you want to calculate the day, the time they made profit or the time they made the loss, you need the dates, I think.
Mhm. Okay, so let's say we're trying to find out like, oh, let's say this day is like till like 2030, say 2010, like they have like different years. Um, you could do stuff with these dates, but most of the times, um, you like for example now, like the question you said now, let's say they're trying to find the time or day they made loss. If you think about that, like as a let's say you're a business owner, like that's not going to be the first set of things you're going to be like thinking of trying to analyze, right? You're like, there are like more important stuff I want to know. Like forget the time that we are doing making sales. It's not even time here, it's even like the day. Is it Monday? Is it Tuesday? It's not even like it's about the fact that like it's like the first day of the week, the third day. So it's like too many information, right? You're like, you know what? Let me take this out first. The reason why we are taking them out is that less is more. When you have fewer columns, I want you guys to be able to think through this like as a data expert. So this is sort of going to be out first of all. Then when we have like, oh, we have like something ready, then we can go back to the original data set. So you can think about what date. No, it's not that important. Let me delete it. Also, looking at time, like what do you guys think with time? I want people to like contribute. What do you guys think with time? Do you think this time like makes sense?
I
Okay.
don't
It's
think
not
we need it.
Okay. So we'll delete this also. So we know why it's not making cogs. I don't know what cogs is. So first of all, let me just delete cogs. Um, gross income rating tax 5%. Really, we don't need it. This is just trying to say that, oh, this is like the 5% of the tax or whatever. So let's just delete this. So you're like, oh, you're deleting everything. Like, what are we going to analyze with? So that is where we'll look at. Now we have CT, we have customer type. Um, so first off is when you want to phrase before you go on analysis, you have to phrase your questions first of all before you want to analyze. So, and one direction is you want to start with univariate questions. So we'll do univariate questions and we'll do bivariate questions. So I'm going to give you guys one univariate question and one bivariate question, and you guys can um help me. Everyone is the question that you asked here that we're going to analyze. And so I'm going to give one univariate question, one bivariate question, and so if you are giving me a question, you're going to tell me is it univariate or bivariate. So let's start with this column. So let's say branch. So I can say like uh uh branch is sounding, but I think that should be for me. What is the distribution of branch we have? Okay. Okay, so let me show you what I wrote. I say what branch has the highest number of customers? So this is like our customer data set, right? So if this is a univariate question, so I'm just kind of do like a sort of like a bar chart. I can't do it in mean because it's a categorical data. So remember what I spoke about in the stuff, right? So I said so you're just going to do like a bar chart of we'll do like a bar chart of the highest number of branch, and you could also phrase this question as uh or like, oh, what is the distribution of branches in this data set? So if I want to do something like a categorical data, most times for you to have an insight as to a categorical data, you want to always match the categorical data with the numerical data. So I can say um uh so we see here, right? So this by question is, so what's the total number of quantity sold by each branch? So I'm going to be using the branch column and the quantity column. And I can also say is that what branch sold the highest quantity. Which branch sold the highest? So which branch uses branch column and the quantity column. So I want people to like give me. So you're going to tell me the columns that we are going to use. Column um to use columns. Yes, sir. Columns. Let's do columns. So column. So we have I'm going to use branch. So yeah, I'm going to use branch and what do you call it? I said and quantity. Quantity. So anybody wants to give me like a univariate question? So we'll get two for each. We get two more, and we're just going to run our analysis. Any univariate question? Anyone? Oh, this is just the only one we want to do. I know this stuff. You guys are the one that probably so I want you so just try. You can't be wrong. That's why we are correcting. We can give you feedback right on this call. Anybody?
Okay. What is the total sales made by each branch?
Is that a bivariate or univariate?
That should be bivariate.
Okay, it says what is the total sales made by each branch? You see how kind of simple it is, right? So what columns are you going to be using for that?
We have total and branch.
Total and branch. And that's all like data analysis. So imagine you have this pictured in your mind already. So you know what you're looking for. Even though there are tens of columns and rows, you're like, yeah, go ahead. Go ahead, please.
Hello, good evening.
Yeah, good evening.
Okay. What is
Nobody should
the
use branch again. And
what
branch is tired.
what is the mean of the rating?
What is the what?
The mean
Mm-hmm.
of the rate,
So is that a
rating.
bivariate question or univariate question?
Rate.
It's univariate. Okay, so what is the mean of the what?
The rating.
Great. Oh, gross what?
Rating.
Okay, what's the meaning of the rating? Awesome, thank you. So what column are we going to be using for that?
And
Wait, rating, awesome.
and
Yeah, well, thank you. So this could also be says that what is the average rating? So for example, like let's say this rating is 1 to 10. Like if you want to know the average rating, let's some people give 1, some people give 8. So you would know the average rating by like, oh, if let's say the average rating is 7 or 8, that means your organization is like not doing bad. Maybe the average rating is 3. So this is what we do as HR analysts. So you can't just be counting 9.1, 5. What do I think is going to be? Or just make a random guess. No, it doesn't work that way. So one more question for each, then we'll start analysis. Anybody wants to help us? Awesome. You guys are getting it. Really very
Consign.
question. But go ahead, please.
Hello. Okay.
Yeah. Is it
Next,
univariate or bivariate question?
univariate.
Okay.
I ask, what is the total sales?
Mm-hmm. What is the total sales? Awesome. This is a very good question. So you see, when you what columns are we going to be using?
From the total.
Total. So when you like have your analysis, you have to think about what is like the most important questions, right? So first of all, somebody wants to know like how much did we even make? Like total sales. So total sales is just basically going to you be like summing it up, right? And part of the analysis doesn't need like technical difficulties. So whatever question we have here, you could literally go to Google or YouTube, because assuming you are doing like coding, right? I would say you use ChatGPT, but like ChatGPT probably might help you a little bit, but it might not be very descriptive. Just say, oh, how do I get the total column in Excel? So you're just going to be calling them column, or for a for a numerical variable. So because Excel might not know what is total sales, you can just, or how do I get the mean of a numerical variable? How do I get the the categorical branch of something? Just, I mean, rephrase the question, but like I'm just trying to say that even though you don't know how to run analysis, so far you can phrase the question and the question makes sense and you are good to go. So let's do one more question and we'll go dive into this analysis. So one more bivariate question. Anybody wants to help us with a bivariate question? Don't use the columns that we've used. The other columns that are here. Somebody wants to use like product line, gender, unit price, payments, gross margin. Anybody? Maybe you guys are tracking. Anybody want to help us? Our time is fast spent already. It's already past 11. So 1 hour into the time already. Sorry, past 5 p.m. for you guys.
Okay. You can also
Yeah.
method by city.
What do you say?
What payment method
Payment
or by
method.
gender?
Okay, payment method by gender. Okay, by gender. So we want to know like, oh, are females like paying more with credit card, or they are paying more with cash or with e-wallet? So the columns you're going to be using is like payments and gender. I don't know if you guys are really feeling good about this already. Now, so let me give you a quick insight as to how analysis work, and this is very quite like interesting, right? So I use like majorly a different type of a data analysis. So I don't use Excel every day, but I know how to use Excel. My Excel is more of like a self-taught kind of thing. So, but there's no really tool that you can use that you can't transfer into another tool, because everything is fundamental. Like you try with just, oh, go check a YouTube video. How do I do this type of thing in Excel and things like that? And I'm going to encourage you guys, in case you know how to use Excel, whatever platform, go further to learn more like programming skills, because that's quite easier, like not quite easier, but like that's what most organizations will require of you. So if this is like other programming language, I don't have to like do some additional transformation. Remember like this sheet here, this stuff here I showed you guys earlier. This person did some transform data. They had to like first of all transform the data. Is a dashboard, pivot table. If it's like other programming language, you don't have to first of all be doing that. But Excel requires you to do some transformation. So how do I know if I need to transform a data or not? So when it's a straight up univariate analysis lesson, if it's a straight up univariate analysis and it is in numerical data, you don't need a transformation. So all these univariate, if you just want to let's say we have a univariate question and we do something like what's the total unit price or what's the average unit price, all we just have to come here is, I think there's a shortcut to take this down, but we just do something like see if I want to do this the total, right? I just have to do this, take this up. So you see, just give me the total for each. If I want to do average, average, um, average, I just have to come here and say, let me make this quite interesting. Yeah, and I say average, I just do something like average, just to say what I want to do. So, and if I do this, If I drag this like this, it's going to do the same. It's going to give me the total. So if I draw this, so let's try to do the average for this, for everything, right? See what happens. I'm going to show you what happened. So there's some type of analysis that doesn't look at it, right? It says that this doesn't make sense because it's a category. This is not even me trying to even give you guys some trying to lie to you people. This is a categorical data. So I said you can't do measure of central tendency with a categorical data. So this might work if you have, let's say you have like gender, you have gender called like we have gender, you have like gender. And then gender, we have like maybe male is 1, female is 0, male is 1, female is 0, male 1, female is 0. And like in the code book is, I don't know if I want to go about that today, but let me just, okay. So let's say we have more. And I got ahead to do something like you find the mean. This is too long. A lot of rows. Interesting. I don't have the energy for this. Let me just scroll down. So imagine, let me say I just go ahead to do something like I drag this. So it's going to tell me that the average gender is 0.0. What does that even mean? So there are some things that you should not even do the total for. For example, this rating column, it was like when you tell the boss, oh, the total rating we have is 6,970. So the boss will be like, what are we going to use that for? But we can use the average rating. So you need to know what makes sense, what don't make sense, what can we do total for, what can we not do total for. So based on what I said that if you have a question that is univariate but it's numerical, you can just come to like the end part and do it. But if it's a categorical data and it's numerical, you have to first of all transform the data. Because for some reason Excel can't do some things. So if I just come straight up here and go to like, for the most part, the columns, this is what you'll be using. Stats, you'll be using this charts. This chart. So if I do like this, it's not gonna work. It's just gonna be like, oh, what are you trying to do? It's not gonna work. So I have to like first of all transform data, go to insert. I could just do literally recommended pivot. So when I do recommended pivot, I could do, and this is very simple. You know what I do? I would just like move things around and like play around it and see, oh, what's happening? And say, okay, let me just drag this to columns and say, oh, this is not looking nice. Let me drag this to rows. It's not looking nice. Let me drag this to branch. This is a branch. So this is count. Let me count it to filter. It's not looking nice. Okay. Let me count this to, sorry, a second. Do this. I don't know why this is okay. Sorts of. I think most time you want to, even for pivot table, you probably want to copy two stuff. But I just want to, let me try with one. Let me just do pivot table. Okay. No. I usually do recommend it. So insert pivot. I want to do something like quite label names. I think you most likely want you to have two stuff. Let me see if this will work for a bar chart. Not columns, not rows. Values. This is the total count. Let me see if this will work for a recommended chart. Okay. Okay, so let's just click on this. Recommended chart working. Comment the chart. Okay, let me just click two columns. So we'll come back to having to pick two. So most times, what works for pivot tables? So let's answer the question based off of this analysis. Insert, insert, insert. So most time when it's best for pivot table, you want to put the stuff together. So let's do the total quantity sold by each branch. So you want to bring the branch column side by side. Total quantity. And I think that this is what I wanted to show you guys with the playing around with stuff. So you select these two columns. And so this is where I am home. Select the two columns and click on insert, click on recommended pivots. Now, you would move things around and see, oh, this is making sense. This is not making sense. This is not doing well. This is not doing well. So this is not doing well. It's not doing well. It's the rows. So we see, right? So normally I would know when something is, let me go back to what I selected. When it's a numerical data, most times in a pivot table, let me just delete this. Delete. And what I'm trying to do is something that you guys can, how you would play around things yourself. Delete. Thank you. When it's a numerical data, if you select two stuff and it's a numerical data, you want to drag your quantity or your numerical data into the values, and you would drag whatever into columns. We could, assuming we have three stuff, you could do filter here. I think we could do that. So let me do that again so you guys will see. So you see what I did here. I just did two columns. I did insert, recommended pivot. What's it saying? Does it want me to select it again? Command at least requires two rows. I selected two rows already, but whatever. You guys get the gist. So this is, I don't know what this blank means, but cancel. So let's do something like, so if you want to do a bar chart of this, you could come here, recommended chart, but what's not working? Let me just click on this. Literally just, oh, I think it was because I was in recommended charts. So what this is saying is this blank probably, this is showing like the data needs some cleaning, right? So from your visuals, you can see, oh, like, oh, this is potentially how things are wrong. So we see here for this is a bar chart. Like for A, we have about 1859. For B, we have, there's no variation, and there's this somewhere blank that is doing that. So let's say we want to do this by another group, and on the y-axis here, we have the sum of the quantity. So this is how what I did here is not really that much of a complexity. So let's come to this second question. So what's total sales made by each branch? So the same thing, we selected quantity, right? So we just like select so branch again, total sales. So select total. You could do this like without having to copy the MRI, but this is just quite intuitive. Recommended pivots. So you see, recommended pivots got it right the first time. Probably you knew that, oh, this is what you guys wanted to do. Then the same thing, I come here. Let's say you want to do a bar chart for it. It's like a visualization. I don't know, this recommended is supposed to work well. For some reason, it's not working. So I'll just, so it's really not that. So we have a question. So this is what I wanted you guys to get here is having a question and being able to like see the visuals in real time, not the point of making something so complex. I literally showed you guys in the start of this how that from a predetermined data that we have, which I already have my question set, I already did the practice myself. We could run that type of analysis, but I figured out that this is best to not make it look complex because the idea of this meeting is to see or explain to you how data analysis is not as complex as it is. If you want to make something way neater, it's going to take time. Like it's going to take some few weeks for you to like learn practice. So let's do this last one, payment method by gender. So let's just do this. Um, so payment method. So we copy payment. So let's copy payment. So payment method by gender is like two categorical data. So it might look a little bit complicated. So we can just say, well, let's try. Let's see where it goes. Oh, by gender, it's going to be complicated because the issue here is that they are even representing gender is 1 and 0. So Excel is going to see this as okay. Let me use this one. Okay, it's not exam. So let's see how it works. So payment method by gender. I just wanted to use this recommended pivot by ourselves without having to so let's move things around. So we can do say let me filter by payments and let me see gender could be like in let's see gender should be column and there could be values. So yeah, we could say like but it's not giving us the count of gender. Let me see male and female. Okay. This is why. So yeah, it could look messy. So that's why let me just play around it and see what's happening. No filter might not be the right value because it's not a value. So that's why that I say you can't count gender. So data copy. So it's best you do like numerical, categorical. So let's say we say payment method by the total payment. So we want to know people who paid, where they paying with. So I don't want to make any complicated analysis today. So recommended pivot. So let's move. So since it's like we know, oh, this is not where I'm supposed to look at. Rows. What did I just create now? Let me just delete all these ones. Delete so that I don't know where I am. Okay, I have sheets 5, 6, 7, but it might give me the same thing. Okay, delete these. Delete these. Okay. So when you do this last one again, so payment method by its total sales. So we just highlight it. Recommended pivots. The query requires 2 strong rows. Maybe you want it to be the column first. Insert. I doubt if that is okay. So right now he got it out. And we can literally just click on these comps insert. I don't know why I recommended this is not working, but we have this already. So we can see based off of the visualization, right? So going back to our Excel sheet, this is just trying to say, and we can have numerous questions. We can have questions whereby you select like 3 stuff and do, let me see, yeah, and let's see, like, we didn't ask this type of question, but you could literally like do this and insert recommended pivots. So yeah, you can filter, you can say, oh, I want to do, this is showing like 3 information for credit card, for gender, and the total sales. And you can say maybe you want to filter by gender. So I want to maybe make payment rules, right? So this is like for everybody. So let's say we just want to see for just females alone. This is what you saw this visualization. We just say we want to see for just males alone. You see that the result is changing. So it's just like so analysis is something whereby by the time you do this like often, you'll be so used to it. It's like you are almost if you work for an organization, type of analysis that you'll be running will be quite similar. So it's not really that it's just about you having a question that you know, okay, these are the columns of variables that I need. And this is what I want to see. Either I want to show a table or show a visuals, or you know the right and the wrong type of analysis. So this is things you could really literally do with a type of analysis. This is somebody writing a report. On the analysis, I showed this earlier in the class. This is a past student of ours, and this is the Power BI. This is what he did in Power BI. I wanted us to run this analysis replicated, but I figured out that doing something so simple would be the best. So the question is, so what's like the next best? What's the next thing, right? Um, like this webinar is just to like, you know, let me stop share and stop recording. I think I might not need to stop recording. So this webinar is just to like make you see how data analysis is valuable in case you are planning to like, dive into data analysis, and how if you want to learn more, you could reach out to us at Belonti, like you could email us at support@belonti.com, or you could just join our WhatsApp group, like for more information. Precious, do you mind just dropping up to you the link to the WhatsApp group for those on the WhatsApp group chat? So we have like a 4-month like training. Yeah, 3 to 4 month training like program where you would basically learn how to use like Excel, Power BI, and you are going to build your portfolio. We are sticking to that. Just we maybe you will learn the basic of SQL also, because of it's better like to know a tool or two tools very well. But what our training differ from other training program is because we go into like the questions as to how you need to like approach data analysis, not just doing Excel and you can't solve real life problem or questions and all. So other than that, so I'm going to stop the recording. I'm going to give you room for questions. And what do you think about this class? Did you think you learned something? Did you feel like